The session is on software testing. My career mostly was involved towards testing the products, networking products. It little bit had an impact on software engineering as well. So I thought this topic would be very relevant when I deal educational stuff in my channel. So this session is going to be completely about how to understand software testing, what are all the things that you need to remember when you go ahead with software testing. It can also fit embedded testing as well. Whichever testing you do, predominantly you end up in doing testing. So you need to remember certain basic things, and that's what I'm going to give you guys in next 20 minutes or so session. That's going to be a small session, but if you want, I can send you this PPT also. You can just request over an email or in my channel that I want this PPT, so that I can send you that over the mail. Let us go about the agenda. What is testing all about and how important it is? That's the first question I will answer you. Second, how important is a tester's role? How verification and validation are different, and software testing lifecycle, testing types and testing levels both are different. Difference between good and a bad test case, importance of debugging, and finally, globally approved structure of a test case. This is what I'm going to deal with. Now, what is a testing? Testers are seen as one of the most important persons in the industry. I never undermine the value of a developer, they are equally important. But what do the developer do? The developer creates, the tester makes sure that he identifies the bugs in the content developed by the developer, code developed by the developer. Essentially, they make the code, these guys break the code. That's the core difference between these two. First, let us understand what is SDLC. STLC is software development lifecycle, where the steps will start from requirement. After you collect the requirement, you understand the requirement, you agree upon the requirement, you will go with the design. Then once the design is done, even the high level design, everything is done, you will go with implementation, that is the coding phase. Then once it is done, you need to verify, and finally you need to maintain. The phase where we talk about the verification, where we will jump about testing. Now, testers are very important, not just in software industry. Even when you go to embedded systems, even when you go to hardware, even when you go to IoT sector, wherever you go, whenever you make something for the customer, it is to be tested well before time. It is to be delivered to the market only after testing. And there is a phase called maintenance phase as well, which I have mentioned here, which might involve some testing, because sometimes the customers might find some bugs which you need to really fix, and then it has to be tested as well. So we are going to see about all those. Now, a definition is very important for anything that we talk about. So testing, how is it defined? Testing is defined as it is a method to confirm and identify if the developed product meets desired specifications and works as expected. See the point here. I need to test my product against the specifications. I have got some specification. I need to test if it is working fine against the specification, and is it working as desired. Next definition can be to identify and confirm if the design software is appreciable from the design point of view and it does not break any existing modules. Okay, I have already built few modules. I'm going to add few more features to it, like WhatsApp update. I get an update today, I get an update tomorrow. So it should make sure that the previous stuff should not be broken. So that's testing. We will see that if the product will satisfy the end user. That's the major aim that any tester will have. The end user, as an user, when I get the product in hand, I need to feel that okay, this product is good for me, this is comfortable. So I need to see if the end user will feel very comfortable with the product, should not find any bugs with the product. That's the main motto of the tester. So to make it very theoretically very strong definition, we take this out from several references. Software testing can be defined as a method or a process through which one can evaluate a system, right? Either by manual or automated ways. We have two types of testing normally we follow. One is automated testing, another one is manual testing. That's what is specified here. If there are deviations from the requirement, it would reveal the difference between the expected result than the actual ones. So we are going to test a product, and when there is a mistake or when there is a deviation or a variation or a violation from the expected result, that has to be fixed. That's the whole aim of the software testing. Now, before we go into deeper into the testing process, we need to understand what is the difference between a verification and validation. Now see the representation that I have made right hand side. Am I building the software right? Am I building the right software? That's all. This is exactly the difference that we need to understand. Verification is done in order to check if the software is being built right. Validation is done in order to check if the product is the right one that we are building, if the software is the right one that we are building. Here, if it is built right, here are we building the right one. Validation is a process that we are aiming mostly throughout this presentation, because it is the one that is going to be done by testers. Verification can be done by the developers themselves. Please understand, validation checks for right software. Are we building the right software? Are we able to meet the guidelines that are specified on the requirement? That's all done by the testers. This is the major difference between the verification and validation. Now, before further understanding, we need to also understand what is the defect. Here, see that I have a hammer which is completely available in a right shape. Here I have another hammer which has been broken, and this is the defect. The defect is nothing but the difference between the expected product and the product which you have in hand. The difference between the expected code and the code that you have in hand. The difference between the expected behavior and what you provide in hand. That's it, is the defect. Now coming to STLC. STLC is nothing but software testing lifecycle. This is very, very important, and this is one of the phases of SDLC, which is nothing but software development lifecycle. Now you can see that I have requirement analysis at the first level, test planning, test case development, test bed setup, test execution, and closure. So we need to analyze about all these steps quickly. First one, requirement analysis. Just as in case of software development lifecycle, where we collect our requirements from the customer, here we need to look into the customer given requirements and the agreed upon requirements, and we need to identify the test cases based on the requirements. So the planning with respect to what kind of scenarios are we going to test, what kind of test cases are we going to really write, is to be analyzed, and that's what is required. That's what is referred as requirement planning. The next stage is test planning. Okay, sir, I have identified that these are all the requirements that I am going to cover. How am I going to test it? What are all the setup that I would need? What is the expertise that I would need? What is the training that I would need? All these planning, how many resources do I need? All these will be planned under the test planning. Once the planning is done, so now see the hierarchy. I understand what is the requirement. Now I also have plan. I have the sufficient resources with me. I have sufficient manpower with me. All these things are available now with me. Now the next case is to go with test case development. What is test case development? Writing a test case for a particular test scenario is referred as test case development. That's all. For example, I want to test a login feature. I'll write a test case, and that test case will ensure that that particular scenario is working or not. That's it. So this is called test case development. And next level, test bed setup. Okay, sir, you have written the test case. You have written the test case. I mean, the test case development is done. Where will you test it? Where will you implement it? I need a setup. For example, I'm going to test a mobile app. I need the mobile in my hand. I need the app to be installed there, and then only I can test the scenario. So test bed is something that will help you to test the total scenarios of the test cases that you have already identified. Then after you have set up the test bed, you need to execute the test cases. The test cases will be written one after another. Scenarios will be identified in an incremental order, where it could start from the simplest of the login feature till the most complex feature that the system can support. Now you need to start executing the test cases one by one, and finally you can close a test case saying that this scenario has passed, this scenario has failed. Failure means you need to send it across to the developer to fix it further. So that's a different cycle. I'll talk about it later. Now see that it is something like buying a component from a supermarket. I need to know what is my requirement. I need to know if I have budget. I need to clearly come out with the list of checklist content which I need to buy when I go there. And then I will go there, I'll get the basket ready for buying things. I'll start picking one by one. Execution, I'll start picking one by one. I'll pay the bill, close and come out. This is exactly what we are doing. So everything is a planned step-by-step execution. Here, what we have is requirement collection, test planning, test case development, test bed setup, test execution, and finally you say that bye-bye, the test cases are tested. This is what I have covered over a past few minutes. Now, the next topic that we need to listen into is what are all the types of testing that we normally know. Basically, test case can be tested, which means executed manually, or it can be automated. What do you mean by manual testing, or what do you mean by automated testing? Before that, what are all the things that a tester should have in mind? What are all the basic things that I need to look into when I test a product? After I tell you that, we can go into what is called automated testing, where we will select it. First case, does it work? I am testing something. does it work? Second, is it scalable? Today I am feeding only one input by one user. Tomorrow there could be so many users logging into the same system where it might really stumble. So I need to test that situation. Does it affect the existing code? For example, I'm getting an update. Does this update affect the existing code? There are some legacy systems already which are compatible with the existing system. For example, I might have installed some software. Which software which could be affected if I am updating, or which could be affected through my recent updates or through my software? The existing legacy system should not be affected. And is the user interface simple and efficient? Many systems fail because they do not have a easier user interface. So I need to make sure that my user interface is perfect and pakka. Then shall we release it? All these are decided and done by tester. The tester simply tests that if a product can be released to the market. For that to be done, the rest of the questions that I asked you some time back about, does it work, is it scalable, does it affect the existing code, all these come into picture. So this is how a tester has to think. Now coming to the manual versus automated testing. There are so many scenarios that can be automated. What do you mean by automation? I'll write a script, the script will run on itself, it will get you the result. That is called automation. Simple. The scripting can be done with shell scripting, it can be done with TCL, TK, it can be done with Perl, Python, anything. Now, how will I select which is automatable scenarios, which is non-automatable scenarios? Simple. Wherever the user has to really feed input, wherever the user will feel an experience with that particular feature, it is always better to test it manually. For example, the end user will definitely have this feature in hand. The end user will give an input accordingly. The end user has to feel how it works. So all these kind of scenarios wherever automatic testing will not act as a user, manual testing will come into picture. You understand, right? Whenever there is a feature that requires definitely manual intervention, that requires definitely manual attention, it is better that be tested. Other scenarios like repeated testing. For example, I am going to log in 100 times into the system and then see if the login is successful. That can all be automated. I am going to log out 100 times and test. I am going to refresh the page 100 times to see if it is loading properly. All these are the scenarios which does not require so much of human intervention, can be automated, and that's called automated testing. And we have two types of testing, as I told you. One is manual, another one is automated. That's it. So when to automate? When there are a lot of test cases which are repeated in nature, we can automate. When there is a very limited time available for testing, we can automate. That's the most important point. When the requirements are static, which requires no manual intervention, this is what I covered for fast few minutes. So all these will lead you to automated testing. And now there are generally three types of testing methods. One is black box, second one is white box, third one is gray box. I have represented it in a simple diagram here. Black box, the tester does not know what is inside. It is black box. I just test the product as an end user. The tester knows what is the logic inside, what is the content inside, all those details he knows. That's white box. It's very clear. Whenever the tester does not have to care about what is inside, he is lucky, and that is called black box testing. Whenever the tester has to also have the knowledge of the internals, that becomes white box testing, and there it becomes little more complex for the tester because he has to test from both the aspects, where as an end user also as a developer's view that he needs to test. And gray box is nothing but a mix of both. It is in between. Partial knowledge is what is required for the tester to really go ahead with gray box testing. Now, levels of testing. What are all the different levels of testing? Unit testing, integration testing, system testing, acceptance testing, and regression testing. Simple. Unit testing, I am the developer. I am developing a particular module. For example, a camera module is what I am developing. I need to test that before I move it on to the testers team. That's it. I'll make sure that whatever features I have developed is working from my view. That's it. I am developing one function, for example. That function has to be tested completely. As a developer, you need not break your head too much about how it will work when it is going to be integrated. All those testing will be taken care of by professional seasoned testers. Your work is to make sure that your module works fine. So you need to see your module with so much of selfishness now that it works fine. That's the work of the unit testing. Now, I have given an example here. Now the whole body is presented here. If I talk only about this particular unit, it is referred as unit testing. I am going to test only the knee. Now, I come to the next part. I integrate my modules into all the related modules. For example, now I am connecting my FM radio, connect camera, video recording, and maybe SMS, all these together as one particular module which are related to each other. Then that testing is referred as integration testing. Now you can see that the entire leg is analyzed. This is called integration testing. Now system testing, the diagram reveals you the story. When I test the whole system as an end user, that becomes system testing. Regression testing, what do you mean by that? Very simple. Whenever a product is released, it is not 100% perfect. The product gets updates. Just like our mobile, the product gets updates. Just like the operating system, it gets updates as patch files or something like that. So there should be some test cases that are readily available whenever an update is coming in, because to make sure the existing system is not tampered or existing system is not affected whenever you are giving an update. That's what is called as regression testing. What is user acceptance testing? It's a very important term to understand. Whenever a software is ready to be released to the customer, to the buyer, the user acceptance testing has to be done. The point is very simple. You need to feel yourself as a user and then to test the product. It's called user acceptance. Well, yeah, I have completed my product, I have completed the testing, but now it is going to go to the hands of the customer. So before it goes, I need to make sure that I am the customer. What will I feel when I get this product in hand after paying money? Does it worth it? Does it work the way I want? So it is almost like an end user you need to think of, and then you need to create the test scenarios. And finally, we are almost nearing the end of the session. I need to tell you what is testing and debugging. What is the difference between testing and debugging? Most of us have little clarity on this. Now, I have taken a tire here as an example, which does not have air inside, which is punctured. I just test now first to see if there is enough air. I now understood that there is no enough air, and then I started rotating around the tire to see where the puncture is. Now I found out where the puncture is, and then I fix it. This is exactly what is called testing and debugging. I test if something is fine, and then I debug. After I found out where the mistake is, I can fix it. That's it. The tester's role is to identify this particular point where the problem is available. The developers will come and fix it. That's it. When to stop testing? Okay, you can keep testing the product till next product comes out of your company. There is so much of time that you can really test a product. You need to come to a logical conclusion. That's the point. Deadline to release product will make you decide when to stop testing. That's the major point. And then when you feel that, okay boss, there cannot be any more bugs, I think it's pretty comfortable right now, I'm very confident right now, let's release the product. And when your budget is already troubling you, so I got trouble with my budget, I don't have any more money to test, so let's release the product. And requirements are all met fairly, okay, I'll release the product. That's it. Now, the final topic for the session. This is such a quick session, I believe. We have spent close to about 18 minutes. So next 2 minutes, I think we will be able to complete this. Whenever you write a test case, it is very important that you need to mention everything properly. What is the project name that you are working at? What is the test case ID? Because when you refer to someone saying that this is the test case that has failed, you need to also tell what is the test case ID, because they can go through from the test suite. Test suite is the collection of test cases. Title. Then you need to name the test case appropriately. Do not name it with your name, my name, any name. It has to be the appropriate scenario. For example, test case _01 hyphen login hyphen success. This is what you are checking. You are checking for login success. Then which module you are checking in? Who is the author of the test case? Which product version you are testing? For example, each and every product will have so many versions available, and you will have to test all those. Now you need to test the product version. Date of design, tester's ID. So tester's name goes here. So who would test it? Author of the test case is different. The person who tests it is different. I may write test case and someone else could test it. So both their names are to be appropriately given here. A revision history. If the test case underwent some revision, I need to mention it. Now after the testing is completed, I will make sure if there is a bug, I need to rate that bug. And if the test case has to be also prioritized, low, medium, high, I need to do that as well. So when the test case is of highest priority, people will go with it first to complete the testing. Now, I need to describe it in one line first. I need to say what is the test case all about. Before you start scenarios, you may have some assumptions. Mention that assumptions as 1, 2, 3. Preconditions. You may have some preconditions to be met. Then you mention the execution steps one by one very clearly. It has to be very clear. Then expected outcome. what is the outcome that you are expecting out of this test scenario, and then result, pass or fail. If it is pass, I close the test case there. If it is fail, I need to mention the severity as major, minor or critical, and date of execution is to be mentioned properly. That's it. This is the test case structure, and eventually most of the companies follow something similar to this. Now, good versus bad test case. Please understand, we can simply take an example of how to write a good test case or good steps to make a sandwich. We can mention something like this: take vegetable, clean it and cut it into pieces, get clean and fresh bread slices, keep the cut vegetables inside the bread slices, keep it in the sandwich maker for 5 minutes, take the sandwich out and enjoy food. This appears okay, but how it will be when you get this kind of detailed approach? Get the following raw materials to make a veggie sandwich. Mention the vegetables. Then boil the potato, do not overboil it. Grate the carrot. Then you can see that I have made each and every step very clear, and this is far easier for somebody to make a sandwich instead of following the steps. So this is how a test case should be. A test case should be written in such a way that it is very much readable, very much understandable, and it has to be complete in all aspects. It cannot let the tester think on his own and to do something on his own decision. It has to be clearly prescribed. Each and every step has to be clearly prescribed, and that is what a tester will have to follow. I hope you guys enjoy this session. This is such a fundamental topic. I'll come back with more topics in near future. Thank you for following my channel. Good luck.